Okay, so Bollinger Bands. Bollinger Bands idea is based on normal distribution, which was our previous class. If you haven't watched it, you can go ahead and learn about it. Just a quick reminder, normal distribution is this bell curve where it describes the distribution of a random variable. So if the average is here in the middle, we have one standard deviation here and minus one standard deviation here, and we can assume that the distribution of this variable is going to look like this, where most of the values are going to be clustered around the average and 68% of the time in this range. We can also assume that if this variable is out of the range, it's going to probably go back to be here in the center and take a position in the market based on that. But we also learned that there are many problems with these trading strategies, because if the bell curve look like this, it can change over time. So for example, it can get stretched, and if this bell curve gets stretched, that means that our standard deviation is going to be larger, which means that the volatility of the stocks is going to be larger as well, which can cause loss. We also learned that this curve can move. It can move left or right because the average can change during time. So before we tackle these problems, let's just look at the normal distribution and let's think what happens if we flip it on the side. Let's see what happens if we flip this bell on the side. So we're going to have the standard deviation lines, right? So we will have plus one standard deviation and minus one standard deviation. And if we look at the stock prices, not the stock returns, we can assume that they are bouncing here between these two lines. And we can also assume that 68% of the time, as we learned, this price is going to be between these lines. Now we can say that if the price go out of these lines, as we said before, we can take a position because we assume that it's going to go back to normal, to be in this band. Or on the other side, here, let's say the price go out of the band from the top, so we can sell and buy back because we assume it's going to go back to normal. This based on the idea that we have only 16% chance of it to be out of these bands. So let's sketch it different and see how it looks. So let's sketch here a normal stock price, and let's say it changes over time. Let's say it goes up. And in previous class, we calculated the average based on all data points of the year, which means we get a constant value for the average. But if you look at these 2 points, they're pretty far from the average. And these 2 points in the past, right here, they're closer to the average. And that's because the average is not very accurate. It's based on very far results in the past. Let's say instead that in this point, we will calculate the average only based on the previous n points. So let's say n is 5. Let's say for this point, we look only on the previous 5 points. And let's say we find that the average is somewhere around here. Now, in the next point, let's say this red point, we'll also calculate the average here based on the previous 5 points. So 1, 2, 3, 4, 5. So let's say we get something here. And for each point, we will calculate the average based on the previous n points. So let's say we get this here and this here. And if we connect them with the line, you're going to see that the average is going to look something like this, which is more accurate. This is called the moving average. So let's also calculate the standard deviation in the same way. Let's assume that we take a window of n previous results. Let's say in this case it's 5. And we're going to calculate the standard deviation based on the 5 previous results. And for each point, we'll calculate the standard deviation based on the previous 5 results. We're going to get something like this. And if we draw a line between these points, we're going to get something like this. And we are doing the same thing on the bottom, but with minus 1 standard deviation. So we measure 1 minus 1 standard deviation, and we're going to get something look like that. So we get these 2 bands, and the upper band it's the band of 1 standard deviation, and the lower band is -1 standard deviation. So we can also assume, as we learned before, that most of the time the price is going to bounce between these two bands, these 1 standard deviation bands, and it's going to happen around 68% of the time. Let's sketch this again more clean. So let's say we have here uh, stock prices that changes over time, just like that here, and we have the average, the moving average that is more accurate, look like this. Let's say we have the upper band, the upper Bollinger Band here, and the lower Bollinger Band right here. So based on this, we can say that if the price cross the lower band, and there is like 16% chance of this happen, we will take action and we will buy the stock here because we assume that the price will go back to normal. So we'll go right back here and we can take profit. In the same way, if it crossed the upper band, we assume that the price is too high and it's going to go back to normal. So we will sell it here. And when it goes back to normal, we will buy it here. Now here we looked at one plus minus 1 standard deviation bands, but in the same way, we could also look at 2 standard deviation bands because, as you remember, 68% of the time the price is between plus and minus 1 standard deviation, but 95% of the time it's between plus minus 2 standard deviations. So this will give us more stable results. So let's say here 2 standard deviation and 1 standard deviation here. We will also have to decide here at this point, when are we going to take action? So when the price crosses the lower band, when exactly are we going to take action? There is this delta that we will have to calculate. We will see it soon when we write code. So the bands, in other words, as we learned before, are the volatility of this stock. It tells us how volatile it is. So let's go ahead and do this with code. So we import class 4, which is this module, this class. We import here the API module, which we coded in the first class, give us the historical data. And here we import pandas and numpy, which required to manipulate data. And of course, datetime to manipulate dates, and matplotlib to have better visual. So we define the dates. This is the date period. We turn them to objects. If you don't understand those, go to the first and second class and learn about this. Here we get the data frame by using the get underlying function to get historical data. And here you can see that we get a daily historical data. So first we define the window. This is the window for the average. Remember we said that we calculate the moving average based on the previous n results. So the window is n, is the previous 20 results. And the standard deviation multiplier is just a number to decide how many standard deviation we want for our band. You'll see later. So the first thing we are going to do is to calculate the mean, which is the average. And we do it by taking the close price, right? And then we are using the function called rolling, which we used before. Rolling will essentially roll over the data frame and take the previous n results for every data point. So as we saw it in the sketchboard, here we give it the window. The window in this case is 20. So each data point will look 20 data points back and calculate the mean of those 20. So this is called rolling. It gives us the rolling average, or which is the moving average. So after we do that, we want to do the same thing for the standard deviation. So we take the close price and we're using the rolling function and the window of 20 to calculate the standard deviation based on the previous 20 results. So every data point will have the standard deviation based on the previous 20 results. Here we are going to calculate the upper and the lower band, as we saw before. The upper band will be the mean, the average, plus 1 standard deviation. But as you can see, we multiply the standard deviation by this variable called STD multiplier. The STD multiplier is this variable we defined here before to be 175, but let's put it to be 1 to make it simple. So we're going to have the mean plus 1 standard deviation for the upper band, right? And we're going to have the mean minus 1 standard deviation for the lower band. This way we get the 2 bands. And later we want to visualize this to see it. So we're going to use the plot, and here you can see we give it color and label. So we plot the close price, the mean, the upper band, and the lower band. We did this in previous class. You can go ahead and watch it. Okay, so let's run this and see how it looks like. So here's the result. So the black line is the close price. The mean, which is the moving average, is the gray line, and you have the upper and lower band, which are the green and red line. You can see that the price is moving somewhere between them, but many times you can see that it crosses the upper line or the lower line, right? So let's zoom in here a little bit, see more closely how it looks. Okay, so here you can see that the price is somewhere around the moving average, but in this area here it crossed the green, the upper 1 standard deviation, because we know that there is actually 16% chance of it to be there. So let's change the standard deviation. Let's change it from 1 to 175. If we run this now, we are going to have a more wider bands. So you can see here that the green and the red are a bit more higher. Let's zoom in again. So if we look at this area here, you can see that again the black line is somewhere around the average, but many times it's bouncing or dancing around the green line. So it crosses it and go back to normal, but then cross it again. It's not really clear how we can use this. But let's now go and change it into 2 standard deviation. 2 standard deviations. So here, this is what we get. So if we put 2 standard deviation, we can see that the price barely touched the green or the red line, and that's because we know that 95% of the time price is going to be between 2 and minus 2 standard deviation. So you can see that in this case the price is locked much better between our 2 bands. Let's see how we can write some algorithm based on this. So as we did in previous class, let's write backtest, which is the function that backtest, and it's going to get the data frame with all the historical data and the Bollinger Bands that we just calculated. So here's the function. Let's go over it. So we have backtest here. It gets the data frame, and this function is again based on state machine. So we have a state. The first state is called wait. We'll see soon what it means. And here we have the position, which hold the current position price that we took. Delta, we'll explain later what it is, but essentially is when after we cross the band, we are going to take action, going to take a position. And this is in percentage, so 0 to 25%. When we are going to take loss or profit, this is 1%. The data frame in signal, this is the signal column where we are going to mark it with buy or sell signal, and the profit for each deal, for each position that we take. So we're going to iterate over this data frame, although there are many more efficient ways to do it, but this is more clear. And each row will provide us the row and the index of this row. So for each iteration, we're going to take the price, which is the row at close. We're going to use the close column for the price. And we're going to start for the first state. So this state, the wait state, essentially we're waiting for the price to be somewhere around the center of the bands. So it should be very close to the moving average. Once we are there, we are ready to take a position. We don't want to take a position when we are out of the bands. So we're going to ask if the distance between the price and the mean, the absolute price minus mean, the average, we want to check that the distance between the price and the average is smaller than some amount. In this case, is 2% of the mean. So we want to see that there's a very, very low distance between them. That means that the price is somewhere between the bands. If it's true, we change the state to idle, and the position we initiated to 0, and we are plotting this uh, on the curve. You will see later how it looks. We give it the index and the price. So once we're ready to take a position, we are in idle state. Let's see what happened in idle. So in idle state, we can sell or buy, one of these two options. So we wait, and if we see that the price cross the upper band, right? So the price larger than the upper band multiplied by some constant. This constant is the delta that we just talked about before. We want to see the price cross this line not just by a bit, but by some delta. In this case, delta is 0.25%. So we divide it by 100 and add 1, and we want to see that the price is larger than the upper band plus a bit, plus delta. If it happened, we take a position. The position equals the price, right? That's the price we pay to sell. Sorry, that's the price we get because we sold the stock, and we mark it as sell, right? The signal will be marked as sell. And then we will put this on our curve. We will see later what it means, and change the state to sold. We will see what it means. Continue mean go to the next iteration. And the same way to buy, if we have a signal to buy, when is it going to happen? If the price is lower than the lower band, right? If the price crossed the lower band by a bit, how much? Delta. As we did before, delta is 0.25%. So we want the price to be lower than the lower band and a bit less, right? And if that happened, we are taking position. So we mark the position equals price, right? We want to know what price we bought, and we mark this the signal column as buy. We mark it on the curve, and we change the state to bought and continue. So at the end of this, the state is going to be equal sold or equal bought, right? And that means that the next iteration we're going to be or in this state sold or in the state bought. So let's check what they mean. So let's say we are in the state of sold. So let's look. State equal sold. That means we just sold the stock. So now we are waiting or for the price to go up or to go down. If it goes up, we lost, right? So if the price is larger than the position multiplied by 1 plus take loss divided by 100, that means that take loss is 1%. As you remember, we define it here. So it means that if the stock went up by 1%, we will have to take a position, we have to do something. Or the other option is that the stock is lower in 1%. In this case, that means we take profit, right? Because we sold high, we buy low. So take profit is 1%, as you remember here. So if that happened, go up 1% or down 1%, we take a position. So first we calculate P, which is the profit is going to be the position that we pay to sell, that we get when we sold it, minus price. And you can see we round it by 2. We want to have 2 digits after the point. And then we just save the profit on the profit column, and we mark the signal to be buy signal because we sold, so now we buy, right? and we mark this point on the curve. You will see later how it looks, and we annotate. Annotate means that we put a label on it, on this point, and the label in this case will be the profit. All these things will be more clear later when we visualize it. So this annotation, we give it the index and the price, the X and the Y. So here we mark the state, the next state to be wait, because after this we are waiting again to go back to be between the bands. So here we are going to the next state, which is bought. So assuming we just bought the stock, we are now going to wait to take loss or to take profit. So here we take a loss, because if the price is lower than the position, the price we bought minus take loss, which is 1%. So if the price go down by 1%, we want to avoid more loss, right? So in this case, we'll go out, or the price is larger than the position we bought in 1%. Position multiplied by 1 plus take profit in percentage. That means it goes up by 1. So if it goes up by 1 or goes down by 1, we want to sell it. So in this case, here we calculate the profit. The profit is the price now, the price we sell, minus position, which is the price we bought, and we round it into like we did before. Then we're just gonna mark the profit column here. So profit equals P, and we mark the signal as sell, and again we mark the point and annotate it, so we want to see it on the curve. And we change the state to wait, because we want to wait again after this to the next position. We want to wait to be in the middle of the band. Here we just print all the columns that we're interested in, and we print the sum of the profit. The sum of the profit. The profit is for each position, we calculated the profit, as you remember, so we will calculate the sum of the profits. So let's run this and see what happens. Okay, so this is how it looks like. So you can see here that all the gray points are the state called wait that we just showed in the code. The wait state it means that we are somewhere between the two bands and we are ready to take action. We wait for this state. So once we're in this state, you can see, for example, here we are crossing the upper line. So the red points mean that we take a position, we cross the line. So here in this case we sell, and here the green one we buy, but in this case we lost -5. You can see here -5. So let's zoom in and see more clearly how it look. So here, okay, so for example, you can see the price here is crossing the lower band, the red point, and so we buy, right? And this is the standard deviation, and it goes up, the green one, and we earn $5.82 for this position. And right here after, you see the gray line mean we are ready for the next position, because we're somewhere between the curves, between the bands. Here we take another position, the red point, right? We cross the upper one, but in this case, unfortunately, we are selling here back on a loss, because it goes up instead of down, right? When we sell, we want the price to go down and not up. So here it goes up, we lost 4. Here the gray line, the gray point again, we're ready for the next action, and here again we sell on the red point here because we crossed the upper band, and we buy back on a profit 5.14, which is nice. And then you can see here that this is how you want it to look all the time. This is the ideal time when it works. That's how it looks. Here we take another position, but in this case you can see that price keep going up, so we sold here, but price go up again, so we lost 5.88. So if we look at the data frame that we are working with, Let's see. So we have the columns close, lower band, upper band, signal, profit that we just coded. And the first values are none because we are using a window of 20, right? So the first 20 values are not available. Here you can see sell. This is one position we took, and here buy. And all of these is daily data, right? The daily data points. So we go over here and you can see that for each position, when we close the position, you see the profit here. So if we summarize all these profits together, we get minus 0.47. That means that that's per share. So in this case, that means that this strategy didn't work that good. So let's now try to change the standard deviation to be a bit lower and see what happens. So it's now 175. Let's say it's 1.5. Let's run this and see what happens. So we get this, and you can already see that the price is around the upper band much more. So here we have this great point. Here we take a position and get a profit because price goes down. Another position here, but here price goes up, so we take a loss. And again, go back to normal, take another position and take another loss. So already two. We took two losses. And one of the reasons this happens is because as you can see here, price keep going up, and because price keep going up and our band is much more narrow now, it's 1.5 standard deviation, we are going to have more losing positions. Let's zoom in here. So you can see here you see that the price is dancing much more aggressively around the upper band because they are it is much more narrow. So when you do this, you can play a lot with the upper and lower band, or you can play with the window of the moving average. There are many ways to improve this strategy, which we are going to see in the next classes. Okay,